So first we want to prove that every palindrome with an even number of digits is divisible by 11. What is the rule for determining divisibility by 11? We find an alternating sum. So let's use the number given in the example to check how this works. We have 3, 4, 8, 8, 4, 3, or 348,843. So if we were going to do an alternating sum of these digits, we would say we would have a positive 3, so plus 3 minus 4, plus 8 minus 8, plus 4 minus 3. Now notice that we have a palindrome with an even number of digits. There will be two identical numbers in the middle, and they will have different signs. So I have a positive 8 here and a negative 8, positive and a negative. Then the two numbers surrounding them on either side of them will also be the same and have opposite signs. So here I've got a negative 4, and here I've got a positive 4. And once again, the two numbers on either sides of those will once again be the same and have opposite signs. So you can easily see how all those numbers cancel each other out. I've got plus 8, minus 8. They cancel each other out. Minus 4 and plus 4. They cancel each other out. Plus 3 and minus 3. And they cancel each other out. We are left with a remainder of 0. Therefore, the number is divisible by 11. And if you think about this, it will work with any number that's got an even number of digits. So you can try this on your own. Sorry, any palindrome that's got an even number of digits. That was part A. So what about part B? Will this work with an odd number of digits if a palindrome has an odd number of digits? Well, before we go and try to prove whether this might be right, let's try to think of an example that proves this wrong. What is a number that has an odd number of digits and is a palindrome? Let's start with something relatively small, a 3-digit number, say. What is a number that has 3 digits and is divisible by 11 that we already know? How about 121, which happens to be 11 times 11? Now, what if I just add 10 to that and I end up with 131? That's a number that is a palindrome, and it's got an odd number of digits, and 131 is not divisible by 11. Neither is 141. So that's all we need to prove that not every palindrome with an odd number of digits is divisible by 11.